Usually military procurement forms, um, they are just an absolute cure for insomnia, right?
Well, yeah, completely.
Like you expect endless, I don't know, mind-numbing requisitions for standard issue boots or office chairs,
Hmm.
maybe a bulk order of engine coolant.
Right, the usual bureaucratic paperwork.
Exactly. But today, we're looking at a U.S. Army document that, honestly, it reads less like a bureaucratic checklist and a lot more like a prequel to The Matrix.
It really is an incredibly ambitious text. I mean, what we have in front of us is a draft performance work statement, or a PWS,
Right.
and this was issued by the U.S. Army Research Laboratory, specifically out of Aberdeen Proving Ground.
Oh.
This document outlines the military's architectural requirements for C5ISR, which I know is a massive acronym.
Yeah, that's a mouthful.
It stands for Command, Control, Communications, Computers, Combat Systems, Intelligence, Surveillance, and Reconnaissance.
Wow. Okay, mercifully, we are just going to stick to calling it C5ISR for this deep dive.
That's probably for the best.
So our mission today, right here as we're sitting down with you, is to extract the most critical insights from this massive contract request.
Yeah.
We want to look at exactly how the Army plans to achieve what they actually call knowledge superiority and information dominance.
Two very heavy terms.
Yeah, seriously. Okay, let's unpack this because the sheer scale of the technologies they are demanding contractors build, I mean, ranging from neurosynaptic computing to causal artificial intelligence, it represents a total architectural departure from how we currently fight wars.
It really does. And we should probably establish immediately that this PWS, it isn't just some speculative wish list.
Right, it's not sci-fi fan fiction.
Exactly. It is
Yeah.
a highly strategic roadmap. It's funding the Defense Department's high-performance computing modernization program.
Right.
They are actively seeking the contractors who will, lay down the theoretical foundations, write the software, and physically build the infrastructure to make this sci-fi vision a reality, and to do it in tactical environments.
Right, out in the field. So let's start by looking at the brains of the operation. The document mandates research into emerging binary and other novel architecture designs.
Yeah.
And it specifically name drops two things that caught my eye: adiabatic quantum computing and neurosynaptic systems.
Right.
Now, I like to think of traditional binary computing, the ones and zeros running your laptop right now, as this really fast but highly rigid factory assembly line.
That's a good way to picture.
Right. Like it processes things incredibly quickly as long as everything stays exactly in its designated lane.
Exactly right.
But a neurosynaptic system, it abandons that rigid line entirely to mimic like a living, breathing nervous system.
Yeah, that biological analogy is highly accurate because for decades, I mean, the entire digital infrastructure of the military has been built on those binary assembly lines.
Right.
But the sheer volume of data coming off a modern battlefield, it has just outgrown that model. A neurosynaptic architecture processes information more like the human brain.
Which is wild to think about.
It is. It handles multiple, overlapping, messy inputs simultaneously without needing them perfectly sorted first. And importantly, they pair that requirement with adiabatic quantum computing.
Which, okay, we need to pause and define that because quantum computing is a huge buzzword that gets thrown around a lot.
Oh, absolutely.
So how does adiabatic quantum computing differ from the fragile quantum computers we usually hear about in the news?
Well, standard quantum computing, it relies on these delicate logic gates that can be disrupted by a single stray photon or even a slight temperature change.
Right, they need those giant sub-zero freezers.
Exactly. But adiabatic quantum computing is a totally different approach. Instead of running complex, fragile gate operations, it slowly evolves a physical system to find the lowest possible energy state.
Okay, lost me a bit there.
So think of it like letting a marble roll down a highly complex, bumpy hill.
Okay.
You just let it roll until it settles into the deepest valley.
Oh, I see.
And that valley represents the optimal solution to your equation. It's a method that is theoretically much more stable and resilient.
Which is absolutely vital, right? If you're trying to put these computers in a rugged military environment, they can't be delicate.
Exactly.
And that physical environment is a major theme in this text. Like, the document specifically pushes for advanced computing at the tactical edge.
Yeah, that's a key phrase.
They want to put advanced artificial intelligence and machine learning directly onto devices out in the mud, in the forest, in the desert.
Right out where the action is.
Right. They want these algorithms optimized using lower-level computing languages. They mentioned C and C++Rs, and even domain-specific languages just to squeeze every single ounce of performance out of the hardware.
Because they have to.
But this brings up a massive physical contradiction, I think. Like, if you are a soldier at the tactical edge, the devices you're carrying are inherently resource constrained.
Oh, absolutely.
So how does a device in a soldier's backpack handle heavy AI workloads without instantly draining the battery or, I don't know, literally melting down from the processor heat?
Well, what's fascinating here is how the document actually architects its way out of that physical limitation.
Okay.
They acknowledge that a single-edge device cannot process the modern battlefield alone. It's impossible.
Right.
Therefore, the PWS emphasizes heavily the research and development of task migration among friendly assets.
Task migration.
Yeah. They are looking to build these highly advanced distributed architectures where the computing load is completely fluid.
So wait, it's not just a network passing finished files back and forth. The computers are actively sharing the computational homework in real time.
Precisely that, yeah. If one soldier's device is overwhelmed by a massive data processing task,
Like what?
say rendering a real-time 3D topographical map based on incoming drone footage.
Oh, wow. Yeah, that would be heavy.
Right. So the network automatically senses that processor strain. It then seamlessly offloads parts of that raw calculation to another friendly asset nearby.
That is insane.
Maybe it borrows processing power from a vehicle's computer a mile away, or, a drone loitering overhead. They're essentially designing a massive, invisible, shared brain floating over the battlefield.
That's incredible. But having a distributed neurosynaptic brain-sharing homework across a combat zone introduces a massive physical bottleneck, doesn't it?
It does.
Because if a drone is offloading a 3D rendering task to a Humvee a mile away, they can't exactly rely on a standard 4G cell tower.
No, definitely not.
The data pipeline has to be instantaneous.
Yeah.
And enormous.
And that leads directly into the PWS's extreme requirements for high-performance networking. You have the brain, like we talked about, but now you need the central nervous system.
Right.
The Army is mandating research into dynamic optical networking, or DON, to create what they call dynamic supercloud computing between DoD supercomputing research centers.
And they're getting down to the fundamental physics of that communication, too. Like, the contract requires the study of material sciences to reduce the tuning time for telecommunication lasers.
Yes.
They're also leaning really heavily on software-defined networking, or SDN, to manage what they call heterogeneous networks.
Right, which is crucial.
Just to ground that concept for you listening, software-defined networking essentially separates the control plane, the brain directing the traffic, from the data plane, which is the actual physical cables and routers.
That's a great way to put it.
Yeah, it's like having a master traffic cop up in the sky who can instantly turn a one-way street into a 5-lane highway without needing to pave any new roads, just adapting the flow of data dynamically as the battlefield shifts.
And the military environment guarantees that the network will be heterogeneous, meaning it's going to be this chaotic mix of different devices, ages of tech, different communication protocols.
Right, not everything is brand new.
Exactly. You have a brand new satellite talking to a modern drone, which then has to talk to a 20-year-old radio inside a tank.
Oh, man.
And SDN allows them to bridge those diverse systems cleanly.
But the document pushes the networking requirements even further into territory that seems, frankly, almost impossible. Like, it explicitly asks for theoretical research and prototyping for quantum networks using quantum optics infrastructure.
It does, yeah.
Yeah.
Specifically to derive algorithms for distributed computing.
See, wait, I have to push back on the reality of this.
Sure.
Prototyping a quantum optics network for the U.S. Army means putting it in an environment that is vibrating, dirty, and chaotic.
Yeah.
We just established earlier that adiabatic quantum computing is slightly more stable, but quantum networking involves sending entangled photons across actual distances.
Right.
How do you maintain a quantum state in the back of a vibrating Humvee?
Well, that extreme environmental challenge is exactly why the PWS frames this as requiring theoretical research and modeling foundations first.
Okay, so they know it's a long shot right now.
Right. The Army knows they cannot just drop a quantum router into a trench tomorrow, but they are funding the foundational engineering right now because the strategic payoff is, well, survival.
Yeah?
Quantum networks offer speeds that just dwarf our current capabilities, but more importantly, they offer the promise of absolutely unbreakable encryption.
Because the security relies on the literal laws of physics, not just a really difficult math problem.
Exactly.
Like in quantum mechanics, the very act of observing a particle fundamentally changes its state.
That is the core mechanism, yes. If an adversary attempts to tap a quantum network and just observe the data stream, the entangled photons collapse.
Wow.
The network instantly knows it has been compromised because the physical state of the data is altered.
That's wild.
For the military, achieving that level of tamper-proof, instantaneous communication across a distributed supercloud is the ultimate goal of this entire contract.
Okay, so we have a neurosynaptic computing brain at the tactical edge, and we have an optical and quantum nervous system connecting it all together. Here's where it gets really interesting. What actual information is flowing through this massive system? Because the opponent isn't going to just let you process all this data in peace.
No, of course not. The enemy is going to actively try to blind the sensors. They're going to confuse the network and inject poison into the data streams.
Right.
And that physical reality shifts our focus to the third major pillar of this PWS, making sense of chaos. The document specifically requires research into limited, contested, potentially compromised data analysis.
I really want to focus on that phrase, contested data.
Yeah, it's a big one.
Because think of it like trying to complete a 5,000-piece jigsaw puzzle. But while you were trying to assemble the picture, someone else is standing right next to you, actively sneaking fake puzzle pieces into your box.
Right.
And they're taking real pieces out and they're shaking the table.
Yes.
You have to figure out what the final picture is while simultaneously defending the pieces themselves.
That captures the dynamic perfectly. The military expects the enemy to throw fake pieces into the box through electronic warfare and cyber effects.
Right.
So the PWS mandates simulations for large-scale tactical networks that focus heavily on these disruptions. The network must remain resilient even when the data is actively being jammed or spoofed.
And to handle that spoofed data, they need to verify every single piece of information.
Yeah.
Like the document asks for applied research into complex authentication methods, specifically demanding seamless Kerberos authentication across web-based multi-tiered applications.
Yes.
And Kerberos is just a great example of this zero-trust mindset. It's an authentication protocol that doesn't just ask for a password. It uses a really complex system of cryptographic tickets.
It's very rigorous.
Yeah, think of it like a highly secure VIP club. You don't show your ID to every single bartender or bouncer inside. You show your ID once at the front door, and they give you a mathematically unforgeable wristband.
Right, the ticket-granting ticket.
Exactly, the ticket-granting ticket. And you use that wristband to access different areas inside.
Yeah.
It allows devices to constantly prove who they are over an insecure network without ever actually transmitting their passwords, which is critical when the enemy is listening to every signal.
And that zero trust framework, it's the bedrock for the next phase of this document, the AI itself. Because once you authenticate the data, you still have to interpret it. The Army is moving away from simple machine learning, and they are demanding the development of artificial reasoning and interpretable causal models for what they call rare event prediction.
Wait, how does artificial reasoning differ from the machine learning we use today? Because those sound like the same thing to a lot of people.
It's a huge shift. For the last decade, most military machine learning has been focused on simple pattern recognition.
Like identifying an image?
Right. You show an algorithm 1,000,000 pictures of an enemy tank, and it learns the visual pattern to eventually spot a tank on its own.
Sure.
But pattern recognition is incredibly brittle. It fails completely when the data is heavily contested or when it encounters a truly rare event it has never been trained on.
Because it only knows what it's seen.
Exactly. If the enemy knows what pattern your AI is looking for, they will simply change their pattern.
So they spoof the visual data or hide the tank, and the pattern matching AI is just totally blind.
Which is why the PWS mandates causal discovery.
Okay.
The military doesn't just want an AI that spots a statistical anomaly. They want an AI that understands the underlying physical cause of that anomaly.
Give me an example of that.
Well, if a sensor array on a hill suddenly goes dark, a pattern-matching AI might just register a missing data point.
Right.
But a causal AI model deduces why it went dark. Did the battery die? Did a sudden temperature drop cause a hardware failure? Or did an enemy electronic warfare unit just move into the valley and jam the signal?
Oh, wow.
The goal is to predict a rare event before it happens by understanding the entire chain of cause and effect, even right in the middle of a cyber attack.
That requires, an almost unfathomable level of algorithmic complexity.
Yeah.
The AI has to literally understand the physical world, not just digital numbers on a screen. And that actually brings us to a requirement in this document that feels entirely out of place among all this sci-fi technology.
Yeah, it's a funny shift.
Because we've discussed neurosynaptic architectures, dynamic telecommunication lasers, quantum networks, and causal AI. But someone has to actually write the underlying C++ code.
Someone has to plug the optical lasers in.
Right. And that leads to a uniquely human section of this very technical PWS.
The talent pipeline.
Yes.
The document lays out highly specific requirements for the contractor to manage an extensive summer outreach program.
It's so wild. Amidst all these mandates for information dominance, there is a strict requirement to sponsor high school, undergraduate, and graduate students.
Yeah.
The contractor is required to identify projects, handle the recruiting, and coordinate student and faculty participation in final project demonstrations. They even include like a deeply bureaucratic line requiring the contractor to maintain a safe working environment by enforcing standard operating procedures and ensuring a neat, orderly workspace for the students.
Right. It's basically saying, please build a multi-scale predictive simulation framework to outthink enemy jamming and ensure the interns clean up their desks.
Exactly. But put yourself in the shoes of a high schooler right now. While your friends are lifeguarding or working at a coffee shop for the summer, your summer job is prototyping quantum optics networks or optimizing autonomy stacks for robotic systems at an Army research lab.
It's an incredible opportunity.
It really is.
Yeah.
But why is an education and recruiting program buried so deeply inside a highly classified-sounding C5ISR document?
Well, if we connect this to the bigger picture, it reveals a profound vulnerability.
Okay.
The Department of Defense is fighting a massive existential talent war. You can draft all the performance work statements you want for supercloud architectures and physics-based causal algorithms, but those blueprints are completely useless without a pipeline of brilliant, cleared minds to actually engineer them.
So the military recognizes that human capital is the true bottleneck here, not just the computing power?
Absolutely. The commercial tech sector is fiercely competitive. They offer massive salaries and stock options to the exact same engineers the Army needs.
Right, the Google and Apple salaries.
Exactly. So the DoD is trying to capture these minds early in high school and undergrad, getting them hooked on solving some of the most complex, fascinating physics and computing problems on the planet, with the hope that they will dedicate their careers to building this neurosynaptic future.
So what does this all mean? When we step back from the acronyms and all the technical jargon we've gone through, this deep dive reveals the Army's comprehensive master plan for the coming decades.
It really does.
They are combining novel computing architectures that mimic the human brain. They're connecting them with unbreakable quantum and optical networks and fueling them with causal artificial intelligence they can see through the fog of electronic warfare.
Yeah.
They are building a unified, distributed intelligence across the entire battlefield and simultaneously training the teenagers who will eventually run it.
And this raises an important question, and it's the thought I want to leave you with today, based entirely on the logical conclusion of this text. The document specifically mandates the coupling of multi-physics models with this causal AI.
Let's define multi-physics models before we close.
Right. A multi-physics model means the AI isn't just analyzing digital data on a screen, it is literally calculating how the physical environment affects the hardware and the data.
Wow.
It calculates how the intense heat of a desert sun will alter the performance of a microchip in a drone, or how the specific humidity in the air will physically warp the radio waves transmitting your data.
That's crazy.
The AI incorporates all of that chaotic, real-world physics into its tactical predictions.
It is trying to account for literally every single variable on the battlefield, from the enemy's jamming signals down to the moisture in the air.
Exactly that. So here's the theoretical endpoint. If the military successfully builds what this PWS is asking for, a massive, distributed AI capable of flawless, rare event prediction, deep causal reasoning, and multi-physics modeling in heavily contested environments, at what point does military strategy cease to be a human endeavor and become entirely automated?
Wow. I mean, if the machine can predict the battlefield perfectly, analyzing the weather, the enemy's movements, the physical state of every radio, and the causal link between every moving piece,
Right.
and then instantly task migrate the counter strategy across a neurosynaptic network.
Do we even need generals anymore? Or do the human commanders simply become the maintenance crew, just authorizing the algorithm's decisions because the machine's predictive logic has become too complex for a human brain to audit in real time?
That is a staggering but honestly entirely logical conclusion to draw from this document. It begins with upgrading the microchips at the tactical edge, and it ends with the network itself making the tactical call.
Yeah, it's a huge shift.
Well, we want to thank you for joining us on this deep dive. It is dense, highly technical material, but understanding the mechanics Behind these blueprints is how you stay ahead of where the world is actually going. Keep questioning, keep exploring, and we will catch you on the next one.